Welcome to this webinar about the free Maple player. Today we are going to see an example of usage of the free Maple player to distribute solutions developed in Maple to other people who have not accessibility to a Maple license, such as colleagues and co-workers. We are going to see a brief introduction of the free Maple player and in the Maple software stack. Then we are going to see two examples of worksheet building and then computation performed in the free Maple player. The computations will be performed on a Maple player that is installed separately the Maple, so there is no need for an additional Maple license in order to execute the worksheet built in Maple. And then there will be time for questions and closing. Let's start with a brief overview of the Maple software stack. At the core of the stack, there is Maple, that is a software that helps you analyze and solve mathematical problems, both theoretical problems, but also problems that arise from practical problems that have a solution in mathematical theories. It has the world's most advanced symbolic computation engine, together with strong numerics, and has a complete solution development environment that can be very useful for technical organizations. On top of Maple, we find MapleSim, that is an advanced multi-domain system-level modeling and simulation tool that applies modern techniques to reduce model development time and give you a greater insight into system behavior. At the key points of Maple and MapleSim are the code generation that allows you to export Maple code to a variety of other languages, such as Visual Basic or MATLAB or C, Fortran, and so on. And MapleSim gives you a wide array of tools in order to perform hardware-in-the-loop code generation and perform analysis on system behaviors. Additional tools that implement additional features for the Maple soft stack are MapleNet and MapleSim Server for easier deployment of Maple worksheets and MapleSim models, and the compliance with the Modelica language by MapleSim that allows you to extend the already wide variety of MapleSim components with your own components implemented in Modelica language. Today we are going to see the Maple player, that is an additional tool in the Maple toolbox. It is a free software, as we said in the introduction. You can just find it by Googling free Maple player, and requires no Maple license in order to run. It can be used to visualize and solve Maple worksheets. So if your company has a Maple license, but you want to distribute the worksheet you build with Maple to other colleagues, co-workers, collaborators, and so on, you can just give them the worksheet and the free Maple player, and they will be able to execute, not modify, but execute your worksheet. There is also a version for iPad for mobile devices that is available on the Apple Store of the free Maple player. So this option is also included in the package. We are now going to see two examples of worksheet building and then worksheet execution by the free Maple player. My colleague Elio De Marinis will show you the examples.
Okay, thanks, Philip. Yes. Now we are see a simple professional document created in Maple. We have imported in our worksheet some graphical component that are under this menu, like a button, like a label, and a math container, and a dial and meter. Now we are going to create a simple example like this, and I'm going and now I'm going to show how to do this. So we now start opening a new worksheet in Maple. So we have a blank worksheet, and now we are going to use these components that I emphasizes with with my mouse. So we now the first component that we import in our blank worksheet is a label text, and so we also import a math container beside our label component. To import these graphical components, we are just to execute a drag and drop operation. So I select my component, drag and drop inside my blank worksheet. This operation we have to do this operation for importing label and math container. We have to do this for twice. So we are going to drag and drop label and math container like this. Another one. Okay. The example that we see initially is about a kinematics calculation for a dragster. The dragster is a type of a competition vehicle used in drag racing. In particular, in this example, we can see the equation of the dragster motion, and we derive this equation to get first the velocity. So we derive this equation once to get the dragster velocity, and we also derive this dragster velocity equation another time to get the dragster acceleration. So the dragster motion is a uniformly accelerated motion, so we can see the acceleration is constant. We return to our live example. We have imported some some components in our blank worksheet. We imported a label and math container. So in this first math container, we are going to insert our equation related to our dragster motion. So I copy the Maple math code for time reason, and I inserted this equation in our math container. I rewrite this equation with the new Maple syntax. Yes. Okay. Now we must set our text label. So to set our text label related to dragster equation, we are going to click with the right button of the mouse on this component and select the component properties. On component properties, when we selected the component properties, appears a new window with the label properties, and at caption, in the text field related to caption, we have to insert our text for the label. So I copy and paste this text, and I inserted this into the caption. Check, we push OK, and so we can see the text for this label. We do this operation for twice, for velocity and acceleration. So I copy our text from this document. On caption, I paste this text for velocity, and for acceleration, we are I'm going to copy and paste for caption this text. So inside of the second, third math container, we are going to derive this first initial equation. So now I add a button inside my blank worksheet, and when we click on this button, we can see two voice component properties like the other component. So we can insert, instead of button, calculate. Okay, and we can see another voice in this menu, edit click action. If we click on this voice, it appears a new window. In this window, we can see in this line a little help to that is about the common use of the graphical components to get values and to set values. And in this window, in particular, we are going to insert our MapleCloud. So I go to our text file. I prepared our math code to insert in this component. So I copy these two lines and I inserted this in our window. So I'm going to set the math container 1, the first math container, with the derivative of math container 0. And so for the math container 2, for the math container 2, I set the derivation of math container 1. So we return to our example. So if we click on this button, we see the value of the first derivative from this equation. In the third math container, we can see the derivative of this second math container. To arrange this math container, we can click on the math container box, and with the component properties, we can check AutoFit container to arrange our math container. For the second math container, we do the same things, the same operation. For the third math container, we do the same operation. So we arrange our component. Also, we can insert in this blank worksheet a plot container, okay, plot window. Particular, and with the same button, we can show the representation of this function. We are going to plot this function in this window. So now I copy our MapleCloud from this text file, and I paste this code in our window. Save. So if we click on calculator, now we can see our function plotted in this box. Also, we can import some other graphical component, like a tray radio button. So I click on the first radio button. We click on component properties. I copy the text for the first radio button. I insert this text instead of radio button here. We do the same operation for the other two radio buttons. Component properties, caption velocity, and for the third radio button, we copy acceleration and insert in component properties. Okay. Now, when we check one of the radio button, if we check one of these radio button, we are going to change our plot inside this box. So I copy the math code for each radio button, and to insert our math code, we need to click on Edit Click Action and insert, like I've seen before, the math code in this window. Save. We do the same operation for the other two radio buttons. Save. I copy the last. Okay. Now, if we click on one of these radio buttons, the plot change. For dragster velocity, there is this plot because we have derivated once this equation. For the acceleration, we have a constant because if we derive this equation once, we have a number. So another two graphical components that we can see in this example are a dial that we can see here. I drag and drop this component inside my blank worksheet, and a meter, and I put under this component. So we, with the code that we inserted in this component, I link this component with, I link the behavior of this component with this other component. So I copy the code for this component, the Maple math code for this component. I click with a right click on this component. I choose Edit Maple code. So we are going to set the value of math container 2 or math container 2 from dial 0, and we are setting the value of meter 0 from dial 0. Save. If change our component, we can see the behavior change of this component, and we can see also that the acceleration retrieve the values from this component. Now we have now we must arrange this component in a more user-friendly visualization. To do this, we are going to click on Insert. So we choose Table. We click OK. Now I'm choosing a table of 3 rows and 2 columns. I click on OK. It appears a table on this blank worksheet. Now, to arrange this component in a more user-friendly visualization, we are going to select this component, cut, insert it in one of these cells. So we are going to do this operation for other component, and we could arrange our component in the way that we prefer. And the result of this arrangement and the change color of each cell in the table is this. And this is the last. This is the result of our example, and we can share our Maple documents with our colleagues, like Filippo said before, and we can also view another example that I have done with the Maple graphical component like this. In the user that haven't a license a Maple license could use this worksheet in to do his calculation. He could set the values that he prefers, and also he could click on the button that are in this worksheet to change the values for this example. In this example, we are I have created a simple Maple worksheet for a thermal exchanger. So if the user change the values for the internal array and external array, he could retrieve different values for internal temperature and different values for external temperature calculated by using Newton's cooling law and Fourier law. Also, the user can click on this button to see the update of his plot of the plotted function, and also he could change this value inside this text field, and also click in on this button to view the new values for internal temperature and external temperature. So now I'm going to pass the controls to Filippo, because he could use the Maple player, and he can show how to share the Maple worksheet documents for colleagues.
Thank you, Elio, for your examples. Okay, now let's pretend, well, actually, I am a colleague of Elio, so this is a realistic situation. I have the Maple files he just built in Maple. These are the two Maple files. We are going to open them with the Maple player, so that you can see we can execute them just as if I had a full Maple license. This is the dragster example. It's being opened. Okay, as you can see, we have the Maple sheet you just saw in an Elio's example. I can just click calculate to derive the dragster motion equation and get the velocity and acceleration. And I can just scroll to see that we have the same controls in this view, in this environment as in the full Maple environment. I can just use the meter to change the acceleration. As you can see here, the new value is about 12, and if I click on acceleration, the graph is updated to show this value. So the functionalities of the sheet are maintained intact, whether we are in the full Maple environment or the Maple player. We just cannot modify the formulas, the relationship that you saw earlier being built in Maple. Now let's go to the heat exchanger example. In this case, the layout is very similar to what you just saw. We have the constitutive laws applied to this example, the Newton Coulomb law and Fourier's law. We have various parameters for the heat exchanger, and we can just change a few parameters to see that the internal and external temperatures are going to change. Hit calculate, and we see that we have new results, just like in the Maple software. if we go down to the graphs, we see that we also have the graphs updated when I enter a new value for the material parameter, let's say 6, and the graphs are updated. I can also change the way the graphs are plotted this way, that changes the axis position or the selection tool. Let's say I want to inspect a specific point of the graph, and I can do so with the inspection tool, or switch grid lines on and off. So as you can see, this is a full Maple environment just in read-only mode, but it's very useful for spreading the worksheet to other colleagues without needing to buy an extra Maple license just to execute one of your sheets. So if you have any questions, we are here. We are available to answer them, both immediately and via email if you just contact us at the following address.